Today's lesson, we're going to talk about factoring polynomial. We're going to go over two different types of factoring. One is called greatest common factor. The other one is going to be trinomial factoring. When we start trinomial, we will go over several different methods. And you can choose to pick which one you wanted to use. So example 1, factoring out the greatest common factor. When you're looking at a 6x squared plus 3x, we need to find the common between these two numbers. So here you have 6 and 3. Common between 6 and 3 is going to be 3. So you're going to factor 3. And common between x squared and x will be x. Once you factor 3x from 6x, you have 2x remains. So the way that you wanted to make sure you got the greatest common factor is going to be making sure if you multiply these two, you have to have 6x squared back. Plus, if you factor 3x from 3x, you only have 1 remains. And if you have nothing remains, you need to make sure you wanted to put 1 down because you need to have placeholder. If you do 3x times 2x and you say there is nothing remaining and you don't write the placeholder plus 1, then when you multiply back, you only get 6x squared, which is not what we started. So make sure we do write the placeholder. So let me erase this. And let's try the next one. Next one, we have 3 terms. And the first thing we wanted to, when you're trying to factor, first thing you wanted to make sure that you do factor will be the greatest common factor. That's going to reduce your number, that you don't have to deal with the bigger number. So when you're looking at 14, 35, 7 fit in all, and then x to the 4th, x squared x will be the common. So when you factor that, you're going to get 2x cubed remains, because out of 4x you take 1 out, 3 remains, and minus 7 times 5 is 35. Out of 2x you're taking 1, so it will be 1 remains, and minus you're taking whole 7x, so you need to write the placeholder 1. Again, so when you're multiplying back, you need to get whatever you started. So if you multiply this back, we do the distributions, then you're going to get 14x to the 4th minus 35x squared and minus 7x, right? When you multiply back, that's what you need to get if you factor right. So that will be your solution right here when you're factoring greatest common factor. So then the next one, C, when you're factoring this, you have no common between 7 to 1. But one thing that I can factor here is negative 1. Why do you want it to factor negative 1? Because whenever you have left over, you want it to make it positive leading coefficients. So in order to make this positive, you are factoring out negative 1. So when you factor out negative 1, everything stays same but the sign, right? Sign become opposite. What about the next one? You have, so the previous problems, when you look at it, depends on how many terms you have. From each terms, you factor common factor, right? So this one, you had 2 terms. From this 2 terms, common was 3x. This one, you had 3 terms. These 3 terms, common factor was 7x. So this one, when we're looking at it, you need to understand we only have two terms. This is 1, this is 2. So term is separate by addition, subtractions. So this sign right here, subtraction, will differentiate this first part and second part as the first term and second term. So when we're looking at first terms and second term, your common is going to be common multiplication. Common factor is going to be x squared plus 2, x squared plus 2. So when you factor x squared plus 2, so you're factoring this out because that's common, right? What do you have remains? You have x minus 3 remains. Cover this common and see what's remain, right? When you cover it, then you will see x minus negative 3 remains. We learned that when we have a binomial, 2 term, multiply by 2 term, we do the distributions, we do the foiling method. So when we do that, we will have to get back with what we had or what we started. Let's looking at the next one. This is 4 terms. 4 terms, we wanted to find the greatest common factor, but then we don't have any common, right? This one don't have any numbers. That's common with the other ones. This one don't have any variable. That's common with the other ones. So you will not have a greatest common factor. So what you're going to do then, if you have a 4 term, this is only work for 4 term when you have. You're going to use group factoring. First 2 versus last 2 to create a common factor, right? So from first 2, you're going to factor out the common of x squared. Then you're going to get x minus 4 remains. And then when you factor positive 2 from last 2 term, you get x minus 4. This gives you 2 terms. This gives you 2 term again. And this 2 term, your common is x minus 4, x minus 4. So when you factor that x minus 4, you're going to have x squared plus 2 remains. Right. And again, when you do FOIL, you should get this back, right? Let's try one more. So this is 4 term, and I don't see any greatest common factor as it is. Then first thing I'm going to do is, because it's 4 term, I'm going to use the group factoring to create a greatest common factor. So common between first two, I have x squared. Then I get 3x plus 4 remains. And then from last 2, common is negative 2. The reason I wanted to take negative 2 out is because, remember, we're trying to create greatest common factor, right? Trying to create greatest common factor. So whatever it's left over, it should be 3x plus 4. Because you start with negative, both being negative, you have to factor negative 2 in order to get positive 3x, positive 4. So that this 2 is going to be common, right? We're trying to create a common factor. Now you could factor greatest common factor. Then you have x squared minus 2 remain. Now look at factoring trinomial method, right? In order to use this trinomial method, you have to have 3 terms. That's what trinomial means. Whenever you have 3 terms, 1, 2, 3, you could use this method. Well, some of them that you cannot. And then later on chapter, we're going to go over what do we do if we cannot factor. But here, these problems, we'll be able to factor it, because we're trying to learn how to factor if it's factorable. So using the trinomial factoring, there are two different types. The first type is when your leading coefficient is 1, right? So all these problems, you're going to use the same method. When leading coefficient is higher than 1, you're going to use the different method. So let me go over the method that will show you your textbook. So when you're factoring quadratic, you're going to end up getting two linear, right? So we will have x. So in order to get this x squared, you need to multiply x times x. That's the only way that you will get x squared when you FOIL, right? So you know that's going to be x times x always. Then you're going to talk about you're going to think about the sign, right? This sign right here, so sign of the constant, the third term sign, will decide if we're going to have same sign or we have different sign. When this sign is addition, you're going to have same sign. So this means same sign. And depends on this sign, it means that that same sign must be positive. So because these two reasons, having a same sign, that same sign must be positive, you're going to have plus plus. And then we're going to write it down, factor of 10, this 10 right here, right? The factor of 10 that gives you addition of 7 will be the number that you're going to write it here. Because you have the same sign, don't matter which number, where you put it, it will be still same factor. So let me write the factor of 10. That's going to be 1 times 10 or 2 times 5. Only two options there. And which one's adding to become 7? That will be this one, right? When you're adding these two numbers, you get 7. So instead of 1 times 10, you're going to use 2 times 5. So it will be 2 here and 5 there. Again, you can rotate the number because the sign is the same, don't really matter. So this is how you're going to find the factor. And we did go over before when you have binomial time binomial, when you do the multiple foiling, right, multiplications, then you should get this back, right? This is just checking. Let me write the checking. So it will be 2x times x, x times 5, 2 times x, 2 times 5. Combine the like term in the middle. That's what you get. So if you use this method that I just showed you, then you will always get the right factor. Okay, so let's try one more, right? Quadratic, factoring will give you 2 linear. This is variable x. You get x squared by multiplying x times x. This sign right here means you're going to have same sign. That same sign must be negative, right? Factor of 8, 1 times 8, 2 times 4, and then 4 times 2, 8 times 1, right? The one that it gives you 6 when you're adding it will be this one, right? So we're going to use those two. Since both of the factor will have negative, don't really matter where you put 2 and 4, that will be your factor. And you can check if you want to, right? So then this one. This is quadratic factor will give you 2 linear. This time when you have negative right there, it means you're going to have different sign. One have to be negative, the other one have to be positive, right? So we know that start with x times x because it was x squared, right? Different sign One is negative, one is positive. And the bigger number have to be negative, because when you combine the like term like you did it right there, right, the negative 1 have to be remain, right? So now find the factor of 12. 1 times 12, 2 times 6, 3 times 4, 4 times 3, 6 times 2, 12 times 1, right? Out of this, add it to become negative 1. Look like I can have negative 4 and positive 3. This is going to give you negative 1, right? So we will pick this options, negative 4 and positive 3. And that will be your factoring. Again, when you check multiplying back, this is what you need to get back, right? And if you did it right, that's what you're going to get all the time. So let's look at the one more. Quadratic factor, you will get 2 linear. It will be different sign. One is positive, one is negative. Different sign. One is positive, one is negative. Factor of 12. That gives you, this time, instead of adding, you're subtracting, or you're adding with the sign, right? So because this is negative means different sign. That gives you 4. So even before I go any further, I can kind of tell this is going to be my options, because if I have positive 6 and negative 2, that will give you positive 4, right? So I will have positive 6, negative 2 will be my factor. Let me try one more. Quadratic factor, you get 2 linear, it will be same sign, right? Same sign, the same sign must be negative. Factor of 12, that gives you same sign, so addition of 2. Let me write that down. I have options of 1 times 12, 2 times 6, 3 times 4. Because it's same sign, addition of 2, there's no way that I can get addition of 2, right? If I add this 2 number, it will be 7. I add that number, 8. That will be 13. I cannot get negative 2. So this one is something that I cannot factor. When you cannot factor, then you will just say this is prime. It's not factorable. So remember I said that if it's not factorable, we're going to learn how to solve the equations using different method, right? Right now we're just learning factoring or reviewing, right? Okay, so then this is going to be different types of factoring. Why is it different? Well, we call the same name factoring by trinomial, but your leading coefficient is no longer 1. Your leading coefficient is higher than 1. Then we're going to use the different method. And this is the one that I'm going to show you, different way of doing it. So the first method that I'm going to show you is using group factoring. So if you went over or learn factoring trinomial method, this is one of the method that everyone's seen it before, which is using group factoring method. In order to use the group factoring method, we know that we're going to use, or we need to have 4 terms. So we wanted to stretch out in the middle term to make it 4 terms so that we can use grouping. But then we cannot just use any number. We need to multiply leading coefficients times constant, which is going to be 2 times 3, which is 6. So factor of 6 that gives you addition or subtractions of 5, that's the number that we're going to end up using. So let's see. It will be 1 times 6, 2 times 3, and 2 times 3, when you're adding those two numbers, it will be 5. So I'm going to use that numbers to stretch out this problem into the 4 terms, right? So we had 2x squared before. 5x become plus 2x plus 3x plus 3. Once you create 4 terms, use first 2 versus last 2 to find the greatest common factor. First 2 look like I have x and 2x as a common factor. Then I get x plus 1 remains. So if I wanted to create x plus 1, look like I'm going to factor positive 3 out. Then it gives me common factor of x plus 1. Then you have 2x plus 3 remains. So that's how you can find your trinomial factoring when leading coefficient is higher than 1. Let's try one more. So first thing I'm going to do is multiplying leading coefficients, right? And constant. That gives me 12. And factor of 12 is what I'm going to look for, right? 1 times 12, 2 times 6, 3 times 4. This time, because it's a sign is different, difference will make negative 1 will be this one. And make sure 4 is negative, 3 is positive, to stretch out this in the middle term to create a 4, right? So then you will get 2x squared to start it, and then negative x become negative 4 plus 3 minus 6. It's up to you where you wanted to write it. You know, I start writing negative 4 before positive 3 because I saw 2 and 3 common. I mean, 2 and 4 common is 2, right? But then if you try 3, I think that will still work. Once you create, that was 4x and 3x. Once you create 4 terms, first 2 versus last 2, factor is x, 2x, common factor. Then you have x minus 2 remains. So you wanted to create x minus 2 from 3x minus 6. You wanted to factor positive 3 then, right? Then x minus 2 is remains. Now you have a common factor, x minus 2. Then you get 2x plus 3 remains. Right? I also wanted to give you different way of doing it. This is the method that I use it. If this is easy enough, you can skip this part. But if you always had a problem factoring trinomial when leading coefficient is higher than 1, because this method is different than when leading coefficient is 1, right? Then maybe look at this, the new method that I'm going to show you, because this is going to be the same method. If you wanted to use it for the other problem, you should be able to do that same thing. So what I do is I will factor 2 and 3. So leading coefficients and constant, I will factor them and write it underneath by vertically. So factor of 2 is 1 times 2. Factor of 3 is 1 times 3. Once you write that down, what I will do is cross multiply. So 1 will multiply to 3, 2 will multiply to 1, and write it here. That's going to give you that will be 2, that will be 3. And when I'm adding these two, whatever the solutions, I have to get this middle number, which is positive 5. And I wanted to make sure if this happened, that's the factor I'm going to get, right? So 2 and 3 look like it will become 5 if this 2 sign is positive, right? It means the one in front, this, is going to be also positive. The one in front of this sign, this is going to be positive also. So what does this first row means? Your first row means that 1x plus 1 will be your factor, and one of your factor, and 2x plus 3 is going to be your second factor. And if you compare with this one, that's what you have, right? So it'll be 1x plus 1 and 2x plus 3. So that's how you can find them. What about if you end up not writing in the right position and you didn't get 5? For example, let me erase this for a second. So let's say if I don't have 1 and 3. If I had 3 and 1, then when I cross multiply, this is going to be 6. This is going to be 1, right? And when I'm adding this, it will be 7. I can't make it 5, making this one positive, this one negative, but that's not how it should, your factor should have, because it's your factor should have the same sign, right? This means you have to have same sign, right? So you know that's not how it works. Then that's when you're going to retry, right? That's when you're going to retry. So this is not the right order. So then you're going to write, okay, so that's not the right order. So I will put 1 here, 3 there. Cross multiplying, I get 2 and 3. When I'm adding it, I get 5. And I have to have positive 5. So that's why both signs have to be positive, right? I'm going to try one more time with the second problem. So if I have 2x squared minus x minus 6, I will write down the factor of 1 and 2. And I know 6, I have more than one factor. I have 1 times 6 and 2 times 3, but I will use 2 and 3. Why am I using 2 and 3 instead of 1 and 6? Because the middle number difference is small. When difference is way smaller than your leading coefficient 2 or constant 6, then you wanted to use the smaller difference number. This difference is 1, this difference is 5, so smaller difference. So that's how I decide to use 2 and 3. When I do cross multiplications, I get 4, I get 3. When I'm adding up, I have to have negative 1. Don't forget my sign have to be different. So if I make 4 negative, 3 positive, this is going to give you 1. So that means my first factor will be negative sign. Second factor will be positive sign, which I will get 1x minus 2 and 2x plus 3. You just need to add x to that. And when you check the solution with this method, you have the same factoring, right? The reason I said this is the method I've been using it since long ago. And I don't forget about this method, because when I come back and redo this problem with leading coefficient 1, you can even use this one, same method, right? Let me try. So I will do, this is 1, so it will be 1 times 1. And then factor of 8, I have 1 times 8, and I have 2 times 4. So because 6 is smaller than any of leading coefficient and constant, so I use the smaller difference, 2 and 4. And if I write 2 there, 4 there, cross multiplying, this will give you 2, this gives you 4, added to become 6. Both numbers have to be negative. It means this first and second factor should be negative. That will give you 1x minus 2 and 1x minus 4, which is going to be same as this, right? So this same method can use it in leading coefficient 1 and leading coefficient higher than 1. So if you wanted to use this method, I'm fine with it. Like I mentioned, there are more than these two methods, right? So you can use whichever method you wanted, just making sure all the problem that you end up using the same method always have to get the same solutions. Let me try one more time with H, problem H. So I'm going to try my method first. So let me write that here. 6x squared plus 11x minus 10. 6, I have 1 times 6 or 2 times 3. But because this number is not really big, let me see if I can use smaller difference. If 2 and 3 don't work out, even by rotating order, you might need to try 1 and 6 also, because this number, we don't know yet, right? It's smaller enough because it's close to your leading coefficient and constant, but still one number bigger, right? And this one, you have 1 times 10, 1 times 10, or 2 times 5. But again, let me start with the smaller difference. If this number was like 20, 30, then I will probably use I will try the bigger difference. But because this is still close to 6 and 10, I will start with smallers. And then when I do cross multiplications, I get 6. This is going to be 10. When I'm adding it, I need to get positive 11. And this is not going to give me 11 even if we have a different sign, right? So then what I will do, I will reorder this one. Let me erase the other one too. And I will put 5 up there and 2 there. That will give me 15, and that will be 4. I can get 11, positive 11. If 15 is positive, 4 is negative. And here again, I had to have different sign, and so it makes sense, right, this time. So the in front of positive will become positive, negative will become negative factor, right? So when I write my factor down, I have 2x plus 5, 3x minus 2. Right. And if I use the grouping method like this one right here, you will end up getting the same thing. Should I show you that? Yep. Okay, so if you wanted to use grouping method, right? Grouping method. You're going to multiply leading coefficients time constant and use the factor of that numbers to see what numbers to distribute this number into 2 terms, right? So it will be 6 times 10 is 60. Factor of 60, that gives you 11, is going to be 15 times 4. I did it here, that's why it's easier to find. But if it's the first time using this method, maybe you need to play with some of the factor of 60. And that's one of the reasons I don't like to use this method, because when you're multiplying leading coefficient constant, sometimes this number, you get really larger. So then you will get 6x squared and plus 15x and minus 4x minus 10. That's how you can stretch this 3 term into 4 term. And first last 2 to create a common factor. 6 and 15 common is 3. X, then you end up getting 2x plus 5. since you need to get 2x plus 5, you need to factor negative 2 then, right? So that I can get 2x positive 5. Common factor of this 2 term, this is subtractions, will be 2x plus 5. And then what's left over? 3x minus 2. Again, like I said, no matter what method you use it, long as you're using it right, you should have the same factor. Now we're going to look at more factoring. And this factoring is not like, okay, here is quadratic equations. We need to be able to combine all the factoring that we learn. So when we get a problem and say factor, the first factoring that I'm going to look for is always greatest common factor so I can reduce the number. When I look at all 3 terms, look like I have x as the common. But because I wanted to make leading coefficient positive, because whenever we're dealing with the factoring trinomial, your leading coefficient have to be positive. So then, instead of just factoring x, I can factor negative x. So that I will make leading coefficient positive on the trinomial, and it will become quadratic again. So sign change. And once you factor greatest common factor, you still have trinomial here. So you wanted to factor that further if you can, right? So I will try to see 2 times 1 and maybe 1 times 6 because 11 is little bigger than 2 and 6, right? So instead of using 2 and 3, I will try 1 and 6 this time. Cross multiplications, 1 times 1 is 1, 2 times 6 is 12, added to become positive 11. 12 have to be positive, 1 have to be negative. And it say your sign have to be different, right? This one say your sign should be different, so it works out. So this is negative, this is positive. It means your complete factor should be you factor negative x out, and this trinomial become 2 linear, which is going to be 2x minus 1 and 1x plus 6. So this is factoring completely. Now let's look at this one right here. Again, it starts with cube, right? It means you have least common factor of x. 3, 5, 12. Okay, this 5, we wanted to make sure we wanted to change it to 15. So I will show you the greatest common factor, right? So I'm changing a problem. We have 3x cubed minus 15x squared plus 12x. Common factor is going to be greatest common factor, 3x. When you factor 3x out, you get x squared minus 5x plus 4 remains. So this is the reason I wanted to do greatest common factor first, if you have one, because then it will reduce the number and easier to factor trinomial, right? Had to be x times x, same sign, that same sign must be negative. Factor of 4 give you 5, will be 4 times 1. So that will be the factor of that problem. Let's try this one. This one, I don't see greatest common factor, right? I don't see greatest common factor. But what do we know is this is 3 terms. 3 term, and also you have last term as the constant. Constant means no variable. And this 2 factor is double. So this is square, this is 4. This double, that's same thing as this quadratic equation, factoring trinomial. Remember, constant, 1 times 2 is 2. So this 2 term exponent is double. So when this 2 exponent is double, last term is constant, and we have 3 term, we can always use trinomial factoring. So this time when you factor, order to get x to the 4th, you have to have x squared times x squared. So that's going to be only thing different. But after that, everything falls same. And then this is going to be negative, means 1 negative, 1 positive, different sign. Factor of 5, that gives you addition of 4. 5 times 1. And 5 have to be negative because when you're adding them, it gives you negative 4, right? So that's how you can factor this one. Same method, but different exponents, right? So this one right here, the next one, same method that we can use. Again, 3 term. 1, 2, 3 terms. 1 is a constant without the variable. This 2 exponent is double, right? So it means I can use this method that I used it, right? Trinomial factoring method. So then, let me see. Order to get x cubed, both have to be, x to the 6, both have to be x cubed. Different sign, that different signs start with negative and positive. Factor of 10, that gives you difference of 3 will be 5 times 2. And had to give you addition of 5, 3, so 5 have to be negative and 2 have to be positive, right? Hopefully you try out on the homework. If you have any question of factoring, email me. We'll see you next class.